Hello friends. This video is brought to you by mywayteaching.com.
We will quickly go through the properties of multiplication of integer. We start with closure property. If we take any two integers, say minus 20, and multiply it with another integer, we get the product as another integer. That means on multiplying two integers, we get an integer. Let us take some more examples and try to find out if we have any pair of integers whose product is not an integer. Say we take minus 3 into 0. Our answer is 0, which is also an integer. If we take 5 into 2, it is 10, again an integer. So we cannot find any pair of integers whose product is not an integer. Hence we can say integers are closed under multiplication. In general, for all integers a and b, a multiplied by b is an integer. Next is commutative property. Let us check if the order in which we multiply matters. If we multiply 3 with minus 4, we get minus 12. And if we multiply minus 4 with 3, again the answer is minus 12. That means the order in which we multiply doesn't matter. Hence, we can say that multiplication is commutative for integers. In general, for any two integers a and b, a multiplied by b equal to b multiplied by a. Next is the existence of multiplicative identity. Say we take any integer minus 5. If we can find an integer which can give us product as the same number, then such a number will be called the multiplicative identity. We know that if we will multiply minus 5 with 1, we will get minus 5. So, 1 is the multiplicative identity. Let us check. With more integers. 6 multiplied by 1 will give us 6. 0 multiplied by 1 will give us 0. Minus 3 multiplied by 1 will give minus 3. This shows that 1 is the multiplicative identity for integers. In general, for any integer a into 1 equal to a. Next property is associative property. We take three integers, say 3, minus 2 and minus 5. Now to perform multiplication, we group 3 and minus 2 together and then multiply by minus 5. Or the other group can be, we can group minus 2 and minus 5 together and multiply by 3. If the grouping will not change our answer, then we will be in a position to say that integers are associative under multiplication. So let us check for the answers for these two groupings. We solve the first grouping and get minus 6 into minus 5 plus and so both the answers are same, implying that we can say that since the product of three integers does not depend upon the grouping of integers, so multiplication is associative for integers. In general, if A, B, C are three integers, A into B multiplied by C is equal to A into B multiplied by C. Let us check the existence of multiplicative inverse for integers. Let us take any integer minus 3. If we can find another integer such that their product gives us 1, which is actually our multiplicative identity, then the integer will be called multiplicative inverse. Since we cannot find any such integer, so we can say multiplicative inverse does not exist for integers. Next property is the distributive property. This property says that if you have three integers, say 16, 10 and 2, and you are required to perform 16 multiplied by 10 plus 2, then multiplication can be distributed over addition, means that it is same as 16 into 10 plus 16 into 2. It is important to notice that we can open the bracket by multiplying 16 with 10, then keeping the sign plus and then multiplying 16 with 2. Similarly, if we have minus 2, 3 and 5 such that we have to perform minus 2 into 3 plus 5, this can be written as minus 2 into 3 plus minus 2 into 5. We can check for ourselves by solving left hand side and right hand side. We get, on solving left hand side, minus 2 into 3 plus 5 is equal to minus 2 into 8, which is equal to minus 16. And right hand side will give minus 2 into 3 plus minus 2 into 5, which is equal to minus 6 plus minus 10, which will give minus 16. Since on solving we got left hand side equal to right hand side, so we can say distributivity of multiplication over addition is true for integers. In general, for any three integers a, b and c, a into b plus c is equal to a into b plus a into c. Let us also see what happens if we have 4 into 3 minus 8. Let us check if we can distribute multiplication over subtraction. If we can prove left hand side equal to right hand side, then our work is done. So let us start with the left hand side. We get 4 into minus 5, which is equal to minus 20. Let us solve the right hand side. We get 12 minus 32, which is equal to minus 20. So we have got left hand side equal to right hand side. We can take more such examples and check for ourselves, and then our general statement will be that for any three integers a, b and c, a into b minus c is equal to a into b minus a into c. All the properties discussed till now will make the multiplication of integers much easier, and you are advised to remember these properties as it is.